This is Algebra 1B, looking at section 10.6, which is on the distance formula as well as midpoints. To begin with, when we are on a graph and we want to find the distance between 2 points, we can use this distance formula. Now, where did this formula come from? So let's say I have a point here and we're going to give its coordinates x comma 1, y comma 1. And we have another point right here, and we'll call that x comma 2, y comma 2. And our goal is to figure out what is the straight shortest distance between them. Now, because it's going on a diagonal, I can't just count the units. However, if I find the horizontal distance between them and the vertical distance between them, that creates a right triangle. The length of this segment here, highlighted in yellow, is going to be the difference between their x values. X2 minus x1 is the length of this yellow segment. And the length of this green segment is the difference between their y values. Y2 minus y1. If we subtract them, we find that length. The length that we want is this label I'm calling D. So if we square the yellow and square the green, we could say yellow squared plus green squared equals D squared. The yellow is this, the green is that, and this gives us this equation. We take the square root of both sides, we have our distance formula. So this is just a special case of the Pythagorean theorem. As far as the examples go, you can look at the work that I have done on these problems. And ideally, we want, it's nice when we get an answer that's an integer like this one. For the next example, when I did all of the work, I got the square root of 1369. And I want to see if any perfect squares go into it. If not, I can just give the answer as a decimal. So on the next page, we have some practice problems, and you can see my work for these different problems. I just left my answers within the square root sign. I didn't go all the way down to the decimal. I didn't take the square root of 34 and say that's about 5 point whatever. But go through the problem, see if you can verify that you get the same answers that I did. Go ahead and pause the video while you try those problems. When you're ready, then you can move on to the next part. So for this problem number 5, you're given the distance between the 2 points. You're given the coordinates of one of the points and part of the coordinates for the other one. In blue, you see I have the distance formula written down again. I think it's a good habit to write that kind of thing down just so you start to remember the formula better. And then I plugged in what I knew. I knew that the distance was the square root of 34. I plugged 8 and x in for the x values, 9 and 6 in for the y values. I didn't like the fact that there's square roots on both sides, so maybe you can see in red that I squared both sides, so it's just 34 equals 8 minus x squared. Over here on the right, 9 minus 6 is 3. 3 squared is 9, so there's the 9. The next step, going from red to the gray below it, subtract 9 from both sides. That gives us 25 on the left is equal to 8 minus x squared. And then I went back and I took the square root of both sides to get rid of the squared sign on the right. And I should put plus or minus 5 here. And so then if you subtract 8 from both sides, yeah, so I did take that into consideration. The square root of 25, we could call it 5. So 8 minus x is 5, and then solve that equation. But when we took the square root of 25, it also could have been negative 5. So put 8 minus x equals to negative 5 and solve that one. So there's 2 potential answers for this one, so that the distance between our points is equal to exactly the square root of 34. And you can see a quick drawing of that. Here is our point 8 comma 9. And if I'm at 3 comma 6 or at 13 comma 6, either one of them would give us the correct distance of square root of 34. So then, there is our